Now see the next topic, that is electromagnetic induction part 1. Part 1, that is electromagnetic induction. Electromagnetic induction. Right. So see the question number first. Two conducting circular loop of radii R1 and R2 are placed in the same plane. Two conducting loops are given whose radius is R1, second is also R2. Right, are placed in the with their center when R1 is greater than R2. If the mutual inductance M between them will be directly proportional. So you have to find the mutual inductance between them. Inductance. So it is given capital M. So let's see the explanation is asked in 2021. Right, mutual induction is given by M. So see, so formula will be B is equal to mu naught I upon 2 pi R1, right? So your diagram will be looking like this. So this is your R2, this is your R1. R1 is bigger than that, right? Concentric circle we have drawn. And as we know, this is the magnetic field formula we have given at the center of this loop. So right here, this is the first formula. This is called magnetic field at center of the loop, center of loop. So this is the formula given to it, right? And next is magnetic flux. Next is magnetic flux phi. So phi is nothing but it is magnetic field into area. Now put the value of magnetic field from the first equation. It is given by mu naught I upon 2 pi R1 into area is pi R2 square, right? So initial magnetic induction is given by Mi. So you can see that how magnetic field is related. So M will be from 1 and 2. What is M? So see the next slide. So magnetic flux, that is Mi. So instead of B, we have written here Mi, right? Mi. This is your magnetic flux. Magnetic flux, right? So from equation 1 and 2, we are getting Mi as mu naught I upon 2 pi R1 into pi R2 square, right? So M we are getting as directly proportional to R2 square divided by inversely proportional to R1, right? This is the magnetic field induction relation between R2 and R1 also. So please write it down. Then see the next sum. See the next question number second. So question number second is a step down transformer connected to AC main supply of 220 volt, right? So there is transformer having voltage is 220 volt is made to operate at, so it is operated at 11 volt operating range, right? And energy is nothing but given how much watt it is, 44 watt. Its capacity is 44 watt lamp. Ignoring power losses in the transformer, what is the current in the primary circuit? So your transformer diagram is like this, right? This is called primary binding, and this is your secondary binding, secondary binding, right? So let's see, it is asked in 2021. So voltage we know that is 220 volt, initial volt we also know, right? So when there is no power loss, so please remember this formula. when there is no power loss. There is no power loss. So power is given by voltage into current. So it will be voltage of primary into current of primary is equal to voltage of secondary into current into secondary is equal to power, right? So put the value, initial power we know that is of 220 volt. So put here 220. Initial current we know, no, we don't know. In secondary power we know that is 11 volt, right? Into current we know that is how much, or you can write that is 4 also. So it is directly given na 44. So you can find it current from also there. 44 is equal to 11 into I. So I is coming out to be 4 ampere. So I will write here 4, right? So this cancel this in 20 times. So IP will be 4 by 20. So it is 1 upon 5. So answer will be 0.2 ampere. So this is the current in primary. Write it down, this second one, important question. So we'll solve now third sum, and a series LCR. LCR means L for inductor, C for capacitor, and R for resistor. Right. So these three quantities are added in this circuit. So L value is given, that is 5 Henry. H means Henry, unit for inductor. And capacitor, C value is given, that is 80 microfarad. Farad. That is the resistor value is given, that is 40 ohm. This is your resistor whose unit is ohm. This is symbol is called ohm. To the voltage. So they are connected to the 230 volt battery. Right. Having frequency. Angular frequency of the source at what power transferred to the circuit is half of the power at the resonant frequency. It is asked in 2021. 2021. Third sum. So let's see the third sum. So your diagram will be looking like this. Inductor symbol is in the coiled form. Capacitor is parallel plates and resistor is like this. So this is your inductor, this is capacitor, this is your resistor. So it is connected to the AC voltage. Or AC voltage symbol is like this, right? So this is your LCR circuit connected in series, right? So resonance frequency formula we know. So we will use that formula. So it will be resonance frequency. Resonance frequency, whose formula is given by omega naught, that is 1 upon under root of LC, right? So put the value of L and C, you will get resonance frequency. So omega naught is equal to 1 upon under root L. L value is 5 and C value we know. What is C? It is 80 micro. Micro means 10 raised to minus 6. So calculate it, omega naught, that will be coming out to be 50 radian per second, right? So let's see the next value. So half power frequency. So it is given by formula half power frequencies. So it is given by omega is equal to omega naught plus minus of R upon 2L. Right. So omega L is equal to omega naught value we have calculated, right? In the previous slide, you can just mark it out. It is 50 radian per second. So right here 50. And inductor, it is lagging. So it is minus R value we know, that is 40 divided by 2. L value that is given 5, right? So L value is 5 Henry, right? So L here we use 5 and resistance value that is given 40 ohm, right? So I have used here R value. This is your L value. Now calculate it, then you will get the omega L value. So it is 50 minus, this will become 10 and this will cancel it. So it will be 50 minus 4, that will be 46, right? Radian per second. So now calculate the WH. So it is nothing but 50 plus. So I will use here plus. This is following plus and minus also. So it is 40 upon 2 into 5. So this will cancel this part. So it will 50 plus of 4. So it is coming out to be 40 radian per of second. So please write it down, this explanation. It is asked in 2021. So let's see the question number 4. 40 microfarad capacitor is connected to, so capacitor value is given, that is 40 microfarad is connected to the voltage 200 volt and frequency is given, that is 50 hertz. 50 hertz. RMS value of current on the circuit is, it is asked in 2020. So let's see about the explanation. So RMS value we know, IRMS is equal to C omega ERMS, right? C is your capacitor, omega is your frequency. So omega is also given by omega equal to 2 pi f, right? So here omega is angular frequency, and this f is your linear frequency, right? So now calculate ERMS, and ERMS value is given, that is 200 volt, right? So put all this quantity in this first formula, right? In this formula, all the given data. So it will be IRMS. So IRMS is C value we know, that is 40 microfarad. So it will be 40 into 10 raised to the minus 6, right? And omega value we know, that is 2 pi f. So we will use here 2 pi into f value is 50 hertz, right? And ERMS value is 200 volts. So put here 200. Now calculate it, you will get the value. So it is coming out to be 2.5 ampere IRMS. So here main point is to remember this formula, C into omega into ERMS. So please write it down. Now see the question number 5. A series LCR is connected to the AC voltage source when L is removed from the circuit. There is LCR circuit, and when L is removed, right? So the phase difference between voltage and current is, so phi is the angle between what? Current and voltage. So it is given as pi by 3. If instead of C remove the circuit, the phase difference. So N remove the phase difference, we are getting pi by 2. So this is the first case we have observed. Now second is now removing C. C is removed, right? So C value we are removing, then we are getting the phase difference of pi by 3 between the current and voltage. So power factor of this circuit, we have to find it. It is asked in 2020. So let's see the explanation. So power factor is given by, right? So when L is removed, for the first case I am solving, so it will be tan of phi is equal to XC upon R. There is no L, so XC will be remaining there, right? So this is the power factor formula. Power factor formula, right? So can put the value tan theta value pi by 3 is equal to XC upon R. This is the first equation. Now C, when C is removed, tan of phi factor we know, that is XL upon R. So it is tan of pi by 3. So put here pi by 3 is equal to XL upon R, right? So when circuit is at resonance value, right? So write here another statement. This is the first equation. This is your second equation. So when circuit has resonance position, so XC will be equal to XL is equal to XR, right? Then power factor will be given as cos of phi is equal to R upon Z. That time Z becomes equal to R. So it is coming out to be Z upon Z. It is coming out to be 1, right? So cos phi is equal to 1 means phase angle is 0. So please write it down.